Hey, welcome. My name is Martin. I'm the creator of Super Mega Space Game. Here is Game Dev Garage. Super Mega Space Game is very interesting space game based on physics rules. In Coco, I have completed with Cocos Creator, and if you want to check the game, you may want to go to our website supermegaspacegame.com and join the beta program so you can test the game and give us feedback so we can continue developing this game together. I'm making Cocos Creator tutorials in this channel. If you want to see more tutorials, check links in the description, and for Super Mega Space Game, check link in the corner. Okay, let's go for this tutorial now. We are gonna make a Ragdoll setup in Cocos Creator. I have found a free character parts from the internet, and let me show you where you can find this kind of illustrations. This is a free pick, and I have chosen this illustration for the tutorial now. And we are gonna animate this character based on physics rules, and we'll see how we can achieve ragdoll effect in Cocos Creator in 2D physics. Okay, let's start. So I just downloaded the file and separated parts from each other. Actually, normally we can drag and drop these parts into our project, but this is not ideal and far from ideal actually. So I will make them a sprite sheet. There is a free text packer program. This is free texture packer, which helps us to use several sprites, make them together, and use as a single texture atlas. So let me show you how can use it. Actually, I will just use the web app version of free texture packer. Actually, this is a open source project, so one of my projects in Super Mega Space Game, I just modified the source code to make my own alpha channel textures. Maybe we can take a look later. It helped me a lot to reduce the image sizes because I used JPEG rather than PNG. So I will release another video on that topic. So we just put everything together. We can choose different options to pack them together. Normally I just keep them default, and I renamed the file and texture name to character parts. Then I choose Cocos 2D as format. Then hit export. Yes, we download it now. Hop. So I will extract. Okay. This is the texture atlas that we are going to use in our project. So I go to Cocos Creator and drag and drop these files into our assets folder. Okay, now we have one texture and other parts defined in plist file. So this is okay. Now I will drag and drop these files into our scene. Then let's start organizing the parts. So here, let me a second please. I don't know why Cocos Creator crashed and I closed and opened it again. Sometimes unforeseen things happen, so I will pause and restart the recording, so you may see some cuts in scenes, but I don't want to steal your time. Okay, so let's organize this by the parts. I will save project on frequently on steps. Okay, I will just separate things. So this is the body will be here. Maybe we can just move everything aside and bring here. This is the body, this is the left leg 2. Okay, so 2 is here, left leg is here, the right leg 1 is here, right leg 2 here, left leg 1 here. Actually, we can put the origins first, maybe. As you can see, the sprite's anchor point is in the center. We want to rotate this sprite around this point, so we're gonna change anchor point here. If you make this, it's gonna be easy to adjust everything later. So I'll put it here, and I will put it here. Let's see on the side. Okay, seems fine. This is okay. This is also okay. Normally, if you want to animate manually, you should put things in each other as a hierarchy to make animation easy. But in physics, we can define joints between the parts, so we don't need to adjust any hierarchy here. So I will just roughly put things together. This video may take a little more time than others, so take your time, relax. Maybe you can forward. This is just a video. So head part should be here. This is gonna be very interesting because when we animated the shorts, short sides will be animated also. Maybe we can put this in front of body. Okay, normally we can just render sort in hierarchy, then we just add joints to animate. Right arm 2, this is here, but we need to adjust the anchor. There are some shortcuts. Try Q, W, E, R, T, Y. So you will get these tools quickly. I will just put things roughly, so maybe we can adjust further. Actually, we will define the anchor points in physics rigid bodies. This is not here, so I'm sleeping here. Okay, let's adjust it. Fine. Maybe this is too high, so we can adjust it here. Okay, this is right hand. Maybe we can adjust this right arm a little bit that side, because I don't want to overlap anything. In 2D physics, normally we can ignore connected objects, but for example, the right leg will not be connected to right hand, so right hand will be colliding the right leg, so they shouldn't overlap. Actually, we can define a script and check if we should calculate collision between specific two objects. That this is not the subject of this tutorial now. Yeah. Let's adjust this one also like that. Yeah, I won't use these feeds because those are different alternatives, so you can use whichever you want. Okay, it seems fine. Save the scene and I will group everything in one node. character. Okay, I will put everything into where is the character node? Character node center is here. I will move it here. Okay, now it's fine. Body is here, head is here, arm 2, left hand. This is better in hierarchy because we can find easily. Left leg 1, left leg 2, left foot 1, 2, 3. Okay, but this is not really good, so I will change its source because the render order should be different than the hierarchy order. Arm, okay, this is right arm 2, right hand. Maybe we can put arms and legs together, so here is better. Left leg 1, left leg foot 2, leg 2, foot here, leg 1, leg 2, and foot. Okay, this is fine for now. Okay, so let's add physical properties to these objects. So here I want to hide others and just see the body. Then let's add physics collider polygon. Okay, I will click editing and edit. Normally maybe a box collider would be sufficient for physics calculations, but I just want to use other tools to see how it affects. I just draw rough shape. Actually, we don't need this one. Seems fine like this. Okay. Sometimes it doesn't drag if I hit the collider, so I need to hold from the outside of the collider. I will close editing, save, and let's go with head. Head is here. Maybe we can just inactivate the body so we can work easily in head. Physics, join collider, polygon collider, edit. As you can see, the anchor point is here, so collider generated around the anchor point, so we need to adjust it. Okay, this is enough. Okay, I will go for arm. So this is gonna take time. If you got bored, just fast forward. Collider, physics collider, polygon. Don't mix physics colliders with standard colliders, because standard colliders completely different aspect, different feature. Physics collider with physics rules, but other collider works with your custom calculations. For example, if you want to make your own physics rules, if you have enough time. I usually don't have enough time. Or at least I don't want to do, because we already have physics engine working very well. Box 2D. This is okay. Let's go for the next part. Maybe I can hide the camera because it blocks sometimes. Physics components, collider, polygon collider. I need to get a green screen for my background because I don't want to hide the camera all the time, but otherwise it's gonna block everything in the right bottom corner. So green screen may be much better because I can just lean left or right to show my background. Okay, this is fine. Let's go for other parts. And physics, collider, polygon collider, editing. Actually, we can try to regenerate points. Sometimes it works, and it worked now. Yeah, why I didn't think before. What happened here? So I think it changed the anchor. Let me test it out. I moved the anchor and I will edit collider and offset. Okay, good. Right arm 1. I will try automatic method. Physics, polygon. Okay, editing 7. Okay, good. That works well. So I forgot it. Actually, I used this feature a lot in Super Mega Space Game because we had a lot of entities to make physical. Physics, polygon. 7. Great, it works very well. Physics, collider, polygon, editing 7. Wait, this is not fine. I need to adjust it. If you want to remove one point, just control click on it so you can remove. Okay, we also need to adjust the anchor point and edit again to move the collider. Sorry. Okay, we are here for left leg 1. So background is not very good for this model. I will use a little light color on the background. Somehow I choose this illustration, for example, physics collider, polygon. Okay, leg 2. Oops, foot. Okay, we can polygon 7. Okay, now go for leg 2. Physics collider, polygon 7, and regenerate points. Maybe this point is more than enough. Close editing. Go for right leg 1. In this phase we work a lot to define shapes for physics engine, but later everything will be handled by a physics engine. So actually I like this kind of work because actually physics-based games are very suitable for small teams or maybe solo developers. because most of things will be handled by physics engine. So you just have to define rules and define the idea. If you design nice rules, game will be very enjoying. In Super Mega Space game I did it. Everything based physics rules, and you control a spaceship, move items around, and I find it very enjoying actually. I want you to test this Super Mega Space game and let me know what you think about it. I spent a lot of time on it, and I learned game development with that project. Actually, I did it, I make it everything in Cocos Creator in Super Mega Space game. I even customized this engine code. Maybe we can make a tutorial about that project. Okay, we adjusted everything here. We set up the shapes. So we need to define joints in between these parts. So let's go for joints. Actually, I will define joints on child objects, not root objects. So body will not have any joint on it. So on head, I will define joint for head itself to connect it to the body. So I will go for add component, physics component, joint, and I will use revolve joint because I want to make it be able to rotate around an axis, rotate around a point actually. So I will drag and drop body into connected body link here, and immediately you can see the two symbols icons became visible. So that defines the anchor point based on the body itself. If we keep this rotation point here, the physics engine will try to move this blue icon, blue point to this position. For example, if you want to connect these parts from that position, it will rotate around this point. Okay, so this is very flexible if you want to make interesting joints between objects. So you should play and see what's the difference and what's the result. So we have another option here, collide connected. We don't want to collide connected objects because we want to make it move, rotate around this point. So what happens when it's rotates too much? We want to stop it here and here. So we have to define that numbers in reference angle, lower angle, upper angle, and enable limit features. Maybe we can move it a little bit low, then adjust it here. Okay, we don't need sub-pixel perfect matching, so this is enough. If you are obsessive, you can adjust it under 1 pixel maybe, but it's much more than enough for now. So I will just keep everything default, and we will adjust the reference angle, lower and upper angle later. I just want to keep everything default for now to move forward. Okay, let's go with right arm, add joint, physics component, joint, revolve joint. We need to connect the body itself, and adjust the anchor point, joint point actually. Then go for the other one, physics, joint, revolve joint, and we need to drag and drop right arm 01 here, okay, because the connected body will be this one. which one we need to move. Of course, the yellowish joint icon. So because this is the root, this is the child. Okay, so this is gonna be another joint. Physics joint, revolt joint, and this is gonna be joint to right arm 2. Drag and drop here and adjust the joint point, anchor point for the joint. Okay, now we can see the artifact happens here because the legs are in front of the body. Actually, we can move legs behind the body, but I will adjust them later. So let's go for another joint. Physics joint. You can see we have a lot of options here, so I really find enjoying to play with physics. You can make a 2D car very easy way. Another one here. Physics joint, revolve joint, and we need to drag and drop arm 1 and adjust the anchor point. Okay, another for right leg 1. Physics joint, revolve joint, and let's drag and drop the body. This is gonna be the root for this object, and adjust the anchor point. Maybe a little bit more sensitive. Okay, this is gonna be next one. Physics joint, revolve joint, drag and drop. I make it wrong because root 2, root 1, right leg 2. Right leg 2 should be connected to right leg 1. Okay. We just changed the order to render it correctly, but the physics hierarchy will be different. Render right foot will be another part, revolve joint, and we can put leg 2 because this will be connected to leg 2. Okay. Okay, this is gonna be the next. Physics joint, revolve joint. We need to connect with body. Oops. Body here. Anchor point. Actually, I made a little extension to fix these anchor points automatically, but I don't remember where I put them. So I just will make everything manually. Sometimes manual way is better because this is a tutorial. Joint. Oops. There we go. Joint. Revolt. The root will be this guy. And anchor point will be here. We already made this one. We need to make joint for this one. Physics joint, revolve joint, and this is gonna be the root for this object. Okay, more or less we have completed the joints. Let's check everything. I think we forgot this one. Yes, we forgot it. Let's add it jointed revolutes. This is gonna be left arm 2 and anchor point. Always double check everything if you don't want to spend a lot of time on debugging. Yeah, for example, we already made an error. Normally I don't make that much mistake, but working and talking at the same time is not easy for me. This is okay, this is okay, this is okay, this is okay. Seems fine. So let's add a ground here to see the effect. By the way, I don't know if it's saving or not. I think it's frozen. So let me 1 second, please. I just closed and opened a Cocos Creator editor. I don't know why, but it freezed. So let's adjust the render order. We can move body in front of everything. Maybe this is better. Okay, more or less we done. Let's make a ground and let this guy fall down. Render sprite node. This is gonna be just a simple rectangle. Yes, come on. Okay, this is okay. So let's add this rectangle, physics collider, box collider, and make it static. Okay, let's rename it ground. I will put it here because we work with character now. Okay, let's test it. Hope it works. Yeah, nothing happened. Good, good, very good. This is really nice. So maybe we should change this color. Then we need to enable physics engine. So I will add a script here. We can make a folder and Ragdoll. Then we can enable physics here. Okay. I need to get rid of unnecessary things here. Actually, I can open the webcam because we don't have anything to adjust now. I need to cc director dot get physics manager dot enabled equals true. Maybe we can make another node for controlling things. I usually keep things organized. Put it here, main game control, and drag and drop ragdoll. Actually, we could rename it physics enabler. Okay, hope it works. Very good, perfectly works. Let me check it out for a second. Yeah, I've checked everything, and I found that when Creator crashed, didn't saved my latest edits, so this joint wasn't in place, and now we can test, and everything works perfect. Run the game and see what happens here. Yeah, this is great. He looks very comfy. Okay, so maybe we can make this guy smaller and put here, so we can use several obstacles, which is very classic and very well known in Ragdoll games. Maybe these kind of obstacles. We can put physics glider box here and there. Oops, sorry, I don't want to touch. So we can actually log everything here because I don't want to touch them anymore from the editor screen itself. Okay. What happens if he falls down from that much height? So we need to make these guys static. Okay, let's play and see. This is a big mistake. Actually, I just scaled everything to half, but physics engine works with 1 in scale. So let's make scale 1 and use camera to see everything in our scene. Zoom ratio will be 0.5. Normally this camera is gonna be like this, 1280. Yes, this is gonna be our new frame. So let's make things a little wider. Actually, we can just scale this up because I don't want to lose time. Okay, this is gonna be the frame, so I will put this character up here. Maybe we can go a little bit further, maybe 0.3, and we can use this scale to our camera. I don't know if it's perfectly correct, but we'll see. Normally physics work with scale, but joint positions are not well defined for scales. So I made the extension for that reason, but I couldn't find where is it now. So this is gonna be okay. So this is the main camera frame, and hope it works. Ooh. Oh, very sad. Maybe we can adjust things like that way. Or you can play with friction value of these colliders here, but I will keep everything in default now. So let's see. Wow. Perfect. So next step, we can limit the angles of parts. For example, let's limit the head here. Actually, I want to test it a better way, so I will move character here. Where is the center of the camera? Yes, this is okay. I just want to see the character itself. So 1280 and 720. So this is going to be our frame, and this is going to be our character here. So I will make the body of the character static, because I don't want to move everything, so we can't test the limit of the things. Okay, this is gonna be fine. Then we'll go for head. Reference angle will be 0. Actually now it's in 0 now in rotation, and lower angle minus 45 and upper angle 45. Probably it won't work, but let's see. As I remember, there was a 45-degree offset between angles. It worked. Great. They fixed the bug. Actually it was the limits and lower upper angles was offset for 45 degrees. So this is great. So let's adjust others. Let's hide these logs. For this arm 1 joint will be, let's get the angle minus 7. Let's assume it's minus 7. Reference angle will be minus 7. Okay, so what's gonna be the minimum angle? So this should be minimum angle, right? 8. Actually this is gonna be maximum. 8 will be the maximum, and this is gonna be minimum. 128 minus 128. Okay, this is gonna be fine. So let's go for this one and adjust limits. Rotation is 0, so rotation reference angle will be 0. This is gonna be maximum. Yes, 96, and this is gonna be the minimum, minus 8. Minus 8, 9. I forgot it. Well, 95 is okay. This is the minus minimum, this is the maximum, this is the enable limit. So we should enable limit for everybody part. Okay, this is also okay. Let's go for the hand. Minus 15 is the reference angle, and this is gonna be minimum and maximum. Minus 40 and minus 70. Minus 70 and 40, and enable limit. Don't forget to check this box. Okay, go for others. I know this video will be very long, but you can just fast forward, or you can use faster playback speeds on YouTube. So let's see the reference angle. 24. This is gonna be the minimum angle. 228. 128. Right. Actually 7 or 6 better, but 2 is okay. No problem. Normally this arm 2 will be collided to body, so actually it's gonna be limiting itself, but I just want to keep things organized and well defined from beginning. Okay, this is arm 2, and the limit will be 15. 15 is the reference angle. By the way, I need to check if I forgot all the time. Okay, enable limit is okay. Will be minus 95 to 24, 24. Okay, save. It freezed again, so I hope it saved. So let me check it out. Yeah, it's saved from here, so we didn't lost that much thing. So let's go forward. 20 for this guy and enable limits, and this is gonna be minus 45, 90, minus 45, 90. This reference angle should be in between them. So let's go for this part, and 0 rotation is our reference angle. Maybe we can make it 45 to 45. Maybe minus 45, minus 45 and 25. Yes, minus 45 to 25. Okay, it seems fine. Let's go for the next step. Today Cocos froze too often. I don't know why. Maybe there's something wrong with my computer. Maybe I need to restart, but I don't know. Okay, so this is gonna be the next part. 0 rotation, and yeah, 63, maybe 65, and minus 45. Okay, minus 45 and 65. Enable limits, go default position, then similar for the other one. 0, I will put minus 45 and 45 here, just go forward. Same for here, 45 and 45, because these are not important. Save. Oh, I'm happy it's saved. So what happens here? 45, I don't remember, what was it? 45, 25. So it's gonna be 45 minus 25, minus 25 and 45, and enable limit. The default is 0. So we are getting close to the end. 0 angle, and I will copy minus 45 and 65, and this is going to be minus 65, minus 65 to 45, and limit. We can also give motor feature for joint, but this is out of scope of this tutorial now. Yeah, mostly we completed. Let me check the camera and test it. Yeah, it works, but body is static, so we need to make it dynamic to see the real action. Oh, sorry, dynamic is here. Okay, let's run. Very good. What do you think? It's perfect. I really love physics engine. So maybe we can let it fall down from somewhere here. Okay, I will adjust the camera zoom again, and I want to see the camera frame, so I will adjust the size. Normally the size doesn't affect anything in camera, but I just want to visualize in editor here. So this is gonna be perfect simulation of falling ragdoll body. Yeah, it's pretty happy. Left hand is up. Great. So thank you for watching. I have worked a lot for this tutorial and get tired. Hope you like it and hope you develop it for your games. You can find project files in the description, link in the description. Please check my other projects and leave comments below so I can be motivated, so I know you are there and alive. Thank you for watching. See you in the next videos. Bye.